Bro, have you heard? An earthquake is hitting now. Wait, I'm busy. Bro, this is crazy, look!
Good morning, Luzon, Visayas, Mindanao. I'm Kiana Kaganan.
United Forecast, this is
Logarithm Live.
We begin with breaking news in Mindanao, where magnitude 7.1 earthquake strikes offshore near Mindanao Island this morning.
To give us an update and more information, we have reporter Josh Pasagad from the Philippine Institute of Volcanology and Seismology joining us live.
Thank you, Kiana. Yes, the earthquake struck at 10:13 a.m. with an epicenter located in the Celebes Sea, about 106 kilometers southwest of Sangay, Mindanao. At a depth of 620 kilometers, this deep focus quake means that, although it's powerful, its effects on the surface were minimized. We're seeing reports of light shaking in central and southern Mindanao, but significant and structural damages have not been confirmed.
That's reassuring news. Could you clarify if there is an ongoing risk of aftershocks or other potential hazards for the affected areas?
Given the earthquake's depth, aftershocks are unlikely to be felt at the surface. Additionally, tsunami warnings are not issued at the very moment because the depth and the location of the earthquake did not meet the conditions necessary for one. But we still urge residents to remain calm and to follow any local advisories. But for now, there are no immediate safety concerns.
Thank you, Josh, for that update. It's a relief to hear that the impact is minimal, even with such a high magnitude.
Joining us now are two residents who experienced the earthquake. We have Miss Impress from Davao City, one of the areas where light shaking was reported.
Yes, I was a bit shocked this morning. I was at work when we felt slight shaking. Everyone in the office noticed. Some of us stood up, ready to evacuate. But thankfully, the earthquake stopped in a few seconds. We are glad that there is no major damage, and it is always unsettling when an earthquake hits.
Thank you, Miss Impress. We're glad that you are safe.
Next, we have Mr. Carlos from General Santos City. Mister, could you tell us about your experience?
Even though it wasn't strong shaking, my family and I felt it while we were having breakfast. I immediately thought from moving them outside, just in case, but thankfully, it didn't last long. We're grateful that there's no major damage in our area, but it's a reminder to always stay prepared.
Thank you, Mr. Carlos. We're glad you and your family are safe.
We'll continue to monitor the situation in the Philippines and provide any further updates as they come in. Keep tuning in to Logarithm Live.
Just how do you know how strong an earthquake is?
We actually talked about it yesterday. Where did you come from? Does it matter?
So they actually use a Richter scale, and what it does is measure an earthquake's magnitude using a logarithmic equation.
A what scale? Along a what?
Just shut up. So this is the formula that they use. R, which is the magnitude, is equals to 2/3 times the log of E over 10 to the power of 4.14, where E is the energy released in joules.
How do we do this? We only have the magnitude for the given.
Well, actually, I already solved that last night. We can actually use the same formula, but only fill in the magnitude part. So, we plot 7.1 here, and then use the same formula. And what we're gonna do now is we cross-multiply it with these fractions. So, 7.1 times 3 and 2 times 1. So So it's going to be like this, 7.1 times 3 over 2 and with the same formula. Now we solve this practically, we basically solve this, 7.1 times 3 over 2. So we get 10.65. And now, how did log of e minus log of 10 to the power 4.40 come to existence? So actually in logarithm, we have a rule called a quotient rule, wherein the numerator is subtracted to the denominator. So that's why we have log of e minus the denominator log of 10 to the power 4.40. So now, what are we finding again?
The logarithm of e?
Yeah, that's right. So, since we're already finding the logarithm of e, we need to transpose or transfer logarithm of 10 to the power 4.40 to the right side. And when we transpose, the negative sign becomes
Positive.
positive. So it becomes 10.65 plus the logarithm of 10 to the power 4.40. And now here are my notes. Do you see that sign? Do you see log being crossed out?
What's that?
Well, it's that because we have another rule called an exponent rule. The exponent rule means that if the base is 10, which is also 10 here, it's already given. If the base is the same as this right here, then both of these get cancelled out and the answer becomes the exponent. That is why in here 10.65 is added to 4.40. So now we do the most basic thing. 10.65 plus 4.40 is equals to
15.05.
15.05. But actually we cannot use this yet because we need to put this in exponential form. Mark, what's 15.05 equals the log of e in exponential form?
I don't know.
It's actually very easy. 15.05 is our exponent. And our base here is 10 since it's a common logarithm. So 10 is our base. And e is our answer. So it becomes 10 to the power of 15.05 is equals to the logarithm of e. So this is our joules. So we can now use the formula and derive 7.1 magnitude.
So, where can we use this formula?
Well, aside from the Richter scale, we can actually use logarithms in solving decimals or when it comes to sound, but that's a very long topic and we haven't reached that yet, so I'm not going to talk about it. So basically, to conclude everything that I just said, logarithms can actually be very useful because we use logarithms to simplify bigger numbers. You see, just from what I wrote here, you see, the logarithm of e, which is 10 to the power 15.05, is this long. So we can use logarithms in order to simplify it to 10 to the power 15.05.